without further ado, here's Travis to talk about RxSwift. Switch.
Hey Travis, don't forget to record.
Didn't recognize it. Weird.
Clean sheet.
Yeah. What's up?
I was just wondering, I never seen you and Jason here.
I've been here every week, just slowly. Alright, good to go. Hi everyone. I'm Travis. We're going to talk about RxSwift, RxCocoa. And if you want to follow along, I have a different links, but there's not a whole lot. So, let's do the presentation first, get to that later. So, first off, I want to thank Pat and Michael and Travis and Wells and Luca and all y'all for coming out here. I think it's a lot of fun. We meet up once a month, every month. So, just a big thank y'all for making this possible. Back to me though. I'm Travis. I want to do a little bit about who I am so you know where you're getting your information from. I moved to Nashville in 2014, which is when I picked up iOS and Android development at Lincoln. I now work at SERVPRO doing mostly iOS and like 5% Android, trying to up that, but I'm working on it. And most importantly, I am not an expert at RxSwift. I like it, and I have learned a ton about it in doing this presentation, but I'm not an expert. So please throw your questions at me, but don't feel bad if you make me stumble, because I'm learning just like all of you. So let's talk about the goals of this presentation real quick. And you're going to notice I'm going a little bit quick through it because I have a ton of stuff to talk about, and I want to be able to leave time for the important bits, not the intro. So RxSwift is kind of complicated. It definitely has a bit of a learning curve to it, so I can't give you guys an extremely deep understanding of it in just 45 minutes to an hour. So my goal is really to go over a lot of topics, get you guys to understand what tools are available to you, maybe make you understand when you would use RxSwift if you want to do it, and hopefully inspire you to want to try it. I do think it's pretty fun. I do think it makes your code better. I have a practice demo application at the end here which will demonstrate that you can do some pretty cool stuff with not a whole lot of code. And that's always great too. So if you can do powerful stuff with less code, sounds good to me. But before we can talk about what it does, you need to know kind of why it does. Asynchronous stuff is hard, and it's not just iOS applications, it's kind of all programming. There's just a lot of room for error if you don't do it right. But iOS specifically, there's a lot of tools at your disposal for actually doing it. You've got GCD, you've got operation queues. People have their preferences on which one they prefer. There's probably different use cases for each, but even using those, you can still get it wrong sometimes. So kind of annoying, a little bit difficult. On top of that, if you want to observe changes, that can be difficult too. Naturally, a closure is really great, like a really local environment, but if you want to share it across your application, you might use notifications or KBO or some other delegation pattern, but again, we have to ask ourselves when to do which way. Maybe there's a different way to do it. And I just gave a really brief example here of kind of a not too complicated, but maybe possible scenario in your application where someone wants to refresh some data, you download some stuff, once you download it, you're not done yet, you gotta download 2 more things using the data you just downloaded, so now you're making a whole bunch of requests, and when they all finish, you gotta wrap it up nicely, send it back to your view, and then they can see it. Not that hard, I'm sure all of us here have done something similar to that, but it's a little bit lengthy to imagine in your head how you might do that. Maybe we can shorten it just a little bit. So, enter RxSwift. So RxSwift is not the first iteration of the whole reactive X. I'm going to call it the manifesto because it sounds cult-like. It actually started back in 2011, I think, with .NET. I think they were the first ones to do this. And since then, they've been kind of porting to a bunch of different languages. So if you do Java or JavaScript or C++, I think there's different Rx language for all of them, which is pretty cool. Which means that if you do RxSwift and you like it and understand it, and you do one of those other platforms, it's pretty much the same interface. It's different in syntax a little bit, but same concept, same interface, makes it kind of easy to do almost cross-platform logic. Some of you who have been iOS developers for a long time have probably heard of RxCocoa before. I think they also have RxSwift, Swift version of it. You might be thinking, like, is that different than Rx? Is it the same thing? Very similar core concepts, but just a different implementation, different goals. Still good, just you want to be cross-platform, I do Android stuff, so it's handy for me to know Rx because I can do Rx Java the same as I do RxSwift. And what about RxCocoa? I haven't talked about that yet. So RxCocoa is really just the Cocoa layer implementation of RxSwift. It gives you a lot of convenient stuff for observing text fields or button presses, or maybe grabbing notifications, or just kind of interfacing with the Cocoa elements. Oh, and especially URL sessions. They want to talk about that more. But the specification is like 90% RxSwift and like 10% RxCocoa. Once you understand RxSwift, you can kind of apply it to Cocoa yourself, or you'll know where to look for it. So I talked about the core concept, and I love this really creepy hand. There are three core concepts really that we're driving here. The biggest one is the observer pattern, because we want to be reacting, it's the reactive X, to things happening in our application. That can be data happening, that can be UI elements changing, that can be a lot of stuff that goes on in our applications, and we want to be told when these things happen. It's kind of the inversion of the control thing. Secondly, we want to be able to iterate, because when you think about events happening in your application, sometimes they happen a one-off, like you log into your application one time. But what if you're listening for button presses or location changes or something? Sometimes they happen repeatedly. So we need to be able to iterate over those events too. And thirdly, if we're talking about a lot of asynchronous events happening and maybe you want to chain them together or do multiple things, callback hell is real. We've probably all seen it and dealt with it. We don't want that. So we want to be able to compose these asynchronous events in a functional way so we can, like I said, compose them, we can transform them, chain them, do whatever we want with them in a pretty clean way. So that's the goal behind it. Is there anything that can do all three of those? Yes. It's called the observable. This is the core concept. This is the thing, if you listen to nothing else after this, know the observable, because you can do everything in RxSwift with it. Everything that comes after this is like a more specific version of it, or a more specific usage of it. But at the highest level, it all comes down to this. So think of an observable as a sequence, a generic asynchronous sequence. And it can be synchronous too, but in Swift, we want a synchronous sequence. We just use sequence very happily. So you might not use that for this. So what does an observable do? It emits events, specifically 3 types of them. And in Swift, it's just an email with 3 cases in it. Next is whatever we specify as the generic. So if we have an observable that returns maybe your location updates, well, that location object would be emitted during the onNext case. Error is exactly what it sounds like. If something goes wrong, maybe a user's GPS is turned off or something is broken, might get an error. And completion is maybe you don't need that location update anymore and you terminate it. Interesting to note, both error and completion terminate the sequence. So you'll never have both called. One or the other will get called, and actually you don't have to have either called if you manually dispose of your observable, but one or the other will get called normally. By default, when you make an observable, it's like a task or an operation. It doesn't kick itself off. You have to do that. And the way you do that is by subscribing to it, which is listening for events. So with an observable, you make it kind of like a block of logic. You subscribe to it, the events start firing, you listen there. We're good. Caveat, if you have an observable and you attach 2 subscribers to it, it's going to do the logic of that observable twice, once for each subscriber. If you have a network request, that's bad. We're going to talk about that. Just keep that in mind for now. Observables, when they terminate, they're going to dispose of their internal resources. That's really important too. When we have these asynchronous tasks, sometimes we don't need them anymore. Maybe you go to a screen, you start downloading some stuff, the user gets impatient, they go back, but we don't want to keep doing that, we want to cancel it. So we have a way to do that. Lastly, observables can emit 0 or many events. They don't have to emit any events. We make something that's listening for location changes, and they never move. And then we don't need it anymore, so we terminate it. Or it could emit hundreds or thousands, it doesn't matter. So, also important.
Observable emits the event, and the event is the enum. Is that what you're saying?
Yeah, the event isn't associated type enum, it's just generic.
Okay.
And it's that one event, or the whatever the generic type is, it'll emit one at a time, however many times you want it to.
Gotcha.
Good question. So I talked about an observable. Let's talk about how you make them. There are a lot of ways, and you don't use the initializer. There's a bunch of functions given to you on the observable class. I certainly don't have time to talk about all of them, nor would you care about all of them, so I just picked 3. 2 that are kind of whatever, and 1 is really important. So the first one here, observable just. Whatever you give it here, it's going to interpret the type of it, so it's string, and it's going to emit that one value. So if I said observable.just hello world, it's going to emit 2 events. Next with hello world, and then completed. Okay. The next one is from. You give it a collection. In this case, I gave it an array of strings. RxSwift is neato. It's going to emit 5 events. 4 on next, 1 for each of the strings in the array, and then a completion event. Pretty easy. Can't really think of many great use cases for that unless you're trying to already link into other more important observables. But the last one is critical, and it's create. And this is where you get a closure. And that means that in that closure, you define all the logic that you want to execute, so you manually tell it when to emit on next, or on error, or on complete. And the beautiful thing about it being a closure is that it can be asynchronous. So this is where we get into the actual important use cases. So most often, if you're going to make your own observable sequence, you're probably going to use create. So let's talk more about that. Yes?
By emitting something, is that like a broadcast to like anything that's listening in the app? Or?
Right, so remember with observables, the way that you listen to them is by subscribing to them. So whenever an event is emitted, any of these subscribers will get notified using a closure callback. Good question. So more on the observable.create. So that takes you get a closure, and in that closure you're provided an observer parameter. And with that observer parameter, you're able to call methods on it, such as on next, on error, or on completed, or you can do it with just passing the actual enum case if you want to. They give you lots of ways to repeat yourself in RxSwift. So that closure returns a disposable. Remember how I talked about that these observables, they have to dispose of their resources when we get rid of them. This is how you do it. So if, for example, you have a network, let's say, URL session data task. At the end of your create observable, you would put disposables.create, which gives you a closure, task.cancel. What does that mean? It means that if we decide we no longer want this observable, it's going to call that closure. And so our asynchronous task, our download, would be canceled for us. So we don't have to worry about any consequences at the end of whatever we're doing. We just know that it's going to clean itself up for us, which is pretty nice. And I think on the next slide, I have the actual implementation in RxCocoa of that. This is almost exactly what RxCocoa has. I'm going to go very quickly how this works here. Don't worry about the reacting, that's just how Rx exposes all of its functions and stuff. So we have a method that's going to take the URL request and return an observable with a generic tuple here, response and data. So observable.create takes an observer parameter and enclosure. This whole thing here is just making that data task. Typical URL session data task, nothing fancy about it. Once we get the data here, first we've got to make sure that we have a response and data. If we don't, it's going to call on error. In this case, they're using that weird syntax where they're passing the enum case instead of calling the on error function. Personal preference doesn't do anything different. Same thing here, they're just checking to make sure they have valid data. If they do have valid data, they say on next, and they pass that data in the tuple, and then they say that they're done, completed. Now with the task, you actually have to start it, so they do, task.resume, and then with their disposable, they say task.cancel. Now I'm pretty sure that this disposable will get called every time, even if this were to finish, like if on completed gets called, it still calls this block here, but if the task is already finished, calling cancel doesn't do anything. So it's good just to clean up, you don't have to worry about the case of are you double canceling. I'm going to make a sticking point here. I disagree with this implementation. I'm going to come back to it later. There's a better way to do this. I'm going to talk about it in like 2 slides.
So the .on is emitting like one of the responses.
Yes, in this case here, the on method takes a case of that event enum. In 3 cases are next, error, and completed. And because the generic type is a tuple here, that's what they're passing. So that's just their way of saying, okay, this is the next event. Typically, I make my own wrapper for this, and I do the JSON deserialization manually, and then you can have a generic function that takes maybe a decodable generic, and handle that here. So whatever your decoded model object is, gets emitted that way. If that makes any sense. Might just make it more confusing, but hopefully not. don't worry about it too much about the implementation details, just know that that's pretty much how it works for observables.create. We call create, we get an observer, we're able to call the specific events however we want them to be called, and then make sure that we properly dispose of anything. And sometimes we don't have to dispose of things. Sometimes we want to have an event that maybe says something to a background, I don't know, like a file system, where there's nothing to dispose of. Then you can just call disposable.create with no closure. It happens sometimes. In fact, I think in my examples later, we're going to see that. So I talked about subscribing. I want to give you a little bit more details on how that actually works. So subscribing is how we actually listen to the events being emitted by the observable. Like everything else in RxSwift, there's a whole lot of ways to do it, but there's really two that matter. A subscribe method, which gives you the event and a closure, and that way you can switch on the event in different cases. Or they have one where they've already broken the cases into individual closures, on next, on error, on complete. And they actually also give you on disposed, which isn't an event, so to speak, but it's important if you want to listen for when that observable is gone. I find it more useful for like logging personally, but it's an incentive to use the second function if you want more control over it. And you should always, always handle a disposable object. In fact, Swift is very nice because if you don't assign that disposable, because when you subscribe to something, it returns a disposable. And if you don't assign that to a property, Swift gives you that little yellow warning saying unused property, or something like that. So make sure you always take care of that. The easiest way to do it is to declare a dispose bag somewhere in your class, typically if you have it in like your view controller or your view model. When the dispose bag gets deinitialized, it will clear out all the disposables in it. So that means that if you have a dispose bag and your view model gets deallocated, and you have a network request that you've added to that dispose bag, and you leave so the view model gets deallocated, it's going to cancel that request for you. So you don't have to worry. Again, it's all about minimizing the cleanup you have to do manually. It's going to do it all for you. I think I have a couple examples about that too. That's nice. Oh, great, examples. Do that. Okay, so if someone in the future wants to give a talk on how to make playgrounds pretty, I would appreciate that, because I don't apparently know how to do that. Where's the presentation? Oh, is light okay or should I go dark? That's fine. I heard
Yeah, you're right in front.
It's pretty dark. Okay.
Make it a little bigger. Command plus.
Yeah,
Plus.
There we go.
good enough for now? Okay. So, fun fact, you can have playgrounds in your workspaces. Didn't know that. Really handy, especially when you have dependencies like RxSwift. So, yeah, cool, right? So let's look at the very first one here. This is the exact same example that I had in the slides before with just, which whatever you pass into here is going to get emitted. And so I can hit play and it'll do all these for me, but I put the results below them anyway because I knew it would be kind of hard to see it. Okay, we'll start there. So the first one, very simply, just hello world. We subscribe to just by starting meaning. Two events, hello world and completed, which you can see right there. Pretty straightforward. I did the exact same thing duplicated here with a different way of subscribing to it. So here I took the event. Normally you would switch on the event, whereas here we get the two cases, next and completed. Here I'm breaking them into their individual closures. So I say print next, error, or completed. I chose to omit disposed because I don't care about that. And you can see same thing here, next, hello world, and completed. Two ways of doing the same thing, just depends on how you like to do it. A couple other examples. Okay, so from, same thing we talked about in the slides, you give a collection, in this case an array of strings, it interprets that it's a string type observable. You subscribe to it, we've got 3 items in there, so we're going to get 4 total events, 3 of next and 1 of completed. Again, you can see it down there too. Pretty straightforward. Again, probably not something you're going to do too much unless you're going to compose other observables with this information, but it's kind of difficult to do asynchronous examples on the playground, so forgive me for having some simple ones here. But I tried to do a little bit more complicated one at the end here. Just a little bit more detail on how we can create an observable. So I made an error case that would be cute to show you how an error might happen. So we have an observable. I have various type string because it can't infer it from the context. we're given an observer, which is a type any observer. That's just an RxSwift type to indicate that it's an observer. And we have to return a disposable. So here, I say on next Nashville. So you can see down here, it's going to say next Nashville. On error, tourists. Because it extends error. And thinking here, you can call error tourists, and then it would be done. If I were to try to emit another value after error, it wouldn't do anything. Which is kind of nice. I actually thought it would crash when I tried that, but it doesn't. So that's nice. So very, very simple examples of how you can create stuff. We'll get into the more complicated stuff pretty soon. Question?
Is, not that you ever want to do that, but is there a way to emit an error and then still continue?
Yes, so it is. There are ways to do this. You wouldn't do it in the create block. One thing you can do when you're creating your observables here, you can catch your errors. Catch error, just return, or have a handler that does different logic based on it. So if, for example, you have like a network request and you get a 500 back, but in the example that you're working on this, an empty string or array or something, whatever the result might be, it's fine. Like, you don't really care if you get an error, you just want the answer. You can do something like that. There are ways to make it retry too. There's a couple of different ways to handle that. But as far as like in the actual create block, no. You have to do it after the fact. You can make it go back to it, or you can return a different value. But once you call on error or on completed, it stops emitting events from there.
Do you have to like resubscribe or something?
You wouldn't have to necessarily resubscribe. You would just, before you subscribe to it, you would put one of these catch blocks or something like that. Because then, keep in mind, this is all like kind of the builder pattern where really we're just modifying the one whole observable object that still returns an observable. And then if you subscribe to something that has a catch error handler on it, it would never emit an error, which is useful, very useful for UI stuff. You will hear me talk about never wanting to have errors very shortly. Any other questions before I move back to the slides? I have a recap on the first slide, so hopefully it'll cover it. Okay, quick recap. Observables, that's your logic. You put the logic in the observable, you subscribe to it to get the events emitted by the observable. So if you think of the observable as the logic, the observer, or the subscriber as the listener. Disposables, very important. When you subscribe to an observable, you're given a disposable. If you dispose that disposable manually, you're basically turning off the listener. You typically don't do that. There aren't very many cases where I want to manually turn off a listener without disposing it like my entire class, but you could. The disposable object has a dispose method. That's totally an option, but make sure you handle it. Either put it in a dispose bag or put it somewhere where you're manually going to call it. Just don't leave it floating because that's going to be a memory leak, probably. So, just be careful of that. And I think this next slide is on traits. Cool. Traits, this is kind of one of those like tangent topics that I couldn't find a better place to talk about, so I'm going to talk about it before I get into anything deeper. Observables are very broad. I talked about if you learn nothing else from the talk, learn observables. Traits are more specific, and these are really useful, and this is where I mentioned earlier with the URL session wrapper that I disagree with it. This is why. So remember with the observable, it can return 0 or many events, and then it's going to error or it's going to complete. Well, that's really broad, and that's great, and sometimes we want events like that, but other times we don't need that kind of definition. We maybe can do it a little bit tighter, so we better understand our logic. Like a single, which is my personal favorite, because a lot of the time, especially with network requests, you only get one answer. It either worked or it didn't. You're not going to get multiple responses. So a single, instead of returning 0 or many events, it returns exactly 1, or it failed. So, thinking back to this, if this had been returning a single instead of an observable, instead of calling on next not completed, you would have just called on success. It's a different type of event. Singles have their own, success and failure. They should have done that. I think single didn't exist in RxSwift when they made this, and they don't want to break the functionality, but I digress. I wanted to post it on their GitHub thing, but I figured it was just kind of annoying to ask that question, so I didn't do it. So singles return 1. Completables don't return any, they return a completion event or an error. Completables are really useful when you don't care about the result of something. if maybe you're saving something to the file system and you don't care whether it succeeded or failed, or maybe you just, any operation where you don't care about the result other than it worked or it didn't, completable is great. The last one is maybe. I've never actually used a maybe, and I struggle to find a good use case for it, but a maybe can return 0 or 1 event, and then error or completion. I think a good case where you might use a maybe is if you have an observable that returns a collection, and you say like first object on that collection, where you only want the first element in that array, but that array might be empty. So if the array is empty, it's not going to return anything, and if it's not empty, it's going to return the first element. But technically, it's a maybe. I struggle between knowing if I should use a maybe or an optional single sometimes, and I think the answer really comes down to whether or not nil is a valid use case for your response. Just something to think about. All these are optional though, in terms of like, you don't need to use them. If you want to use observables for everything, you totally can. But it's usually best practice to be as specific as you can so you don't leave any kind of ambiguity in your code. There are a couple more RxCocoa specific ones that I'll get to later, but I don't want to get to RxCocoa quite yet. So, traits are really cool. They make it more specific so that it's easier to understand exactly what you expect from your code. Okay, so I mentioned earlier that if you have a single observable and you subscribe to it twice, it's going to do the logic of the observable twice. That's really bad, especially for network requests. It's not always bad, but it's sometimes really bad. So, how do we get around that? There's a lot of ways to do this. The first way, we can call replay and then ref count. 2 operators here, we can talk about what they do. So, calling replay actually converts our observable into a different class called a connectable observable, which is also the same thing the last one here does. A connectable observable is a little bit different, whereas with the regular observable, we start emitting events the moment someone subscribes. With a connectable observable, we don't do that. You can subscribe 100 people to it, or blocks of code or whatever, and it won't start until you call connect. It's a method on the connectable observable class. But we get around that by calling ref count. So ref count is an operator on the connectable observable class which says, I'm going to start it right now, or rather, I'm going to start it when the first subscriber subscribes, and we're going to keep it open, sharing it for any future subscribers until the reference count hits 0. So if we have a block of code, we did network request, and you have 2 listeners to it, and they're both listening, they're going to get the same result. But if it finishes, and there's no one else listening to that observable, it's going to dispose itself. So that's one way to make sure that things clean up nicely, and it still shares it between different subscribers. If you don't want to call 2 different operators, they made it easy on you to have a share operator, which takes a replay count. This is, oh, by the way, the integer here says how many items it's going to emit. I forgot to mention that too. Because we're replaying events, when you subscribe to it, it's going to give you the past number of events based on the integer you pass into it. So you might get historic values if you wanted to. You can give it a 0 and then it won't. But if you do want to, that's pretty powerful too. You might think like, well, when would you want that? When you're using ref count, it's a little bit tricky when you would want historic values because it might dispose itself if no one else is listening. So if you want to keep someone listening, you can always use publish, which by default doesn't return, it doesn't replay values, or I guess you could just call replay itself. But both publish and replay give you a connectable observable, and that'll keep it alive for you. Publish is a very simple one though if you don't want to replay values. It'll keep the observable alive until you call connect, which starts the observable and then dispose of the connection. So long story short, keeps things alive until no one's listening, keeps things alive until you tell it to go away. So there are ways to handle this. This is kind of going to be how RxSwift is. There's a lot of ways to do the exact same stuff all the time. So you're going to have to pick your favorites.
Just want to make sure I got something right. So if I create an observable, I get my create block right from my logic.
Yes.
If someone subscribes to it the first time, it runs my create block. Someone subscribes to it a second time, it runs the create block again.
If you don't do this,
If I don't do this.
yes. The logic in there would be done multiple times.
This is stuff I gotta fix when I get home.
Yeah.
Okay. I want to do it.
That's okay. I feel like I'm stumbling a little bit. Keep going.
Is there a way to know if you're receiving a past event, like a historic event, versus one that was just published?
Good question. And no, not unless you manually try to do that. If if you tried to emit a value, maybe if you made a wrapper that included a timestamp of when it was emitted, but no, you don't get any indication of when that value was created or emitted. You just get your value.
So I think some of the Rx libraries will give you the index of the event in the string, so you get the value as well as like an integer, and the first one would be 0. I don't know if RxSwift does that, but you could zip your values with another observable that's just a counter, right? So you know, oh, is this, if it's 0, it's the first value, if it's 100, it's the 100th value, something like that.
I'll talk about zip in a little bit. I got a good example for that. That's really clever. Yeah, so you can, based on what Pat said there, you can make it yourself, but it's not baked into the library.
Okay, seems like it would be useful to have like some special type of observable that doesn't
Yeah.
values. Sure.
Well, you definitely don't have to return historic values if you don't want to. Again, you can, if you want to do it this way where you keep it alive as long as people listening, you just pass a 0 and it reads like nothing historic. Say they was shared. More specifically, if you don't want it, probably should just use publish because that by default doesn't do that. But the difference being published is when no one's listening, it's still going to be emitting values. So that's really the difference here. Is when no one's listening, that's still pumping out values to no one. This one will dispose itself. Good question?
Yeah, so you can have multiple subscribers on one observable. Can you have one subscriber subscribe to multiple observables?
The closest thing, no, not really. Because the subscriber, to subscribe to something as a function, I don't know how you would abstract that without just like copying the logic. Like, when you subscribe to something, it has an closure, and you could share that closure to different subscriptions, but you still have to call subscribe on the different observables.
Does RxSwift have the consumer protocol?
I don't recognize it.
It might think that you could have a closure that you're hanging on to, and you could use that to subscribe to multiple observables, but you wouldn't know, as the values come in, you wouldn't know where they're coming from.
Right.
Yeah, so you may or may not want to do that, but yeah.
That's, and that you can do. That's the same thing as when you subscribe, you pass a closure to it. Normally you just implement the closure right there, but you could make a property out of it and share it when you subscribe to different observables, but like Pat said, you wouldn't know which one it came from. Unless you did something clever like having the index set on.
More question.
Yeah.
So an observable does keep track of every instance that it's fired in memory.
If you tell it to.
Okay.
So if you don't specify, there isn't a way to say that given an observable, print out its whole history. That doesn't exist unless you make it yourself. But if you wanted to replay the last 10 events and you tell it, hey, keep track of the last 10, whenever you subscribe to it, you get the last 10. There is a different, it's a subject. I'll talk about that later. I'm going to go with no for now. Good. Okay, so hot and cold. Observables by default are what we call cold, which means that when no one's listening, make sure I get this right. Yeah. When no one's listening, you're not doing anything. So when you make an observable, it's just like a task, an operation, nothing's happening. If you make an observable and never subscribe to it, it's like you didn't do anything at all. Unless you do publish and you make it a connectable observable, and then it's going to keep going forever and you tell it to stop. But by default, not connectable observables, just base observables are cold. They only do stuff when you tell them to when you subscribe to them. But again, that's not always what we want. Sometimes we want stuff to keep firing even if we're not listening. I keep going back to location changes because maybe in your application you're constantly listening for that. And you don't maybe have to begin the screen, maybe you use it on the settings screen. You're not listening to that location update right now. But if they go back to their home screen, you might care about it. You might want to get the replayed value of it or something like that. So you might want to make that one hot, which means it's going to keep listening and keep emitting values even if no one's paying attention to it. As I talked about on the last slide, we call publish on an observable. You get a connectable observable that'll last forever until you tell it to stop. That's a classic example of a hot observable. Even if no one's paying attention to it, it's going to keep going. So for some use cases, that might be useful to you. Sometimes it's not. And if you're doing network operations, you wouldn't probably want to use a hot one. That would probably be bad, unless you're streaming something, in which case you would. Oh, and yeah, so I give an example here. Examples of this line right here I stole from somewhere else. It's a good synopsis of it. if the data is produced inside the create block of the observable, generally it's probably cold, but if you're listening to something else, it's maybe hot. So if you're listening to like UI events or location changes or something like that, where you're not making the data, you're just listening to it, you might want that to be hot because you don't control it. But if you are controlling it, it could be like a network request or a background save or a database fetch. That's probably cold. It's just like a good summary of it. Okay, I think there's one thing, I'm probably lying, one of the last class type things before we get into more specific operators and how you actually mutate these. So observables get observed, they get subscribed to, we listen to them, but sometimes we want something where you can both observe it and also send it values, because right now when you create an observable, you give it a block, and we can't inject stuff into that block willy-nilly. You know, it's going to run when it wants to, but we can't update it. These can't. And so subjects are a special kind of, they're not technically observables, I'm just going to call them classes of this, where they can be observed, and also they are observers, and so they are hot, and that's why I had the previous slide on hot versus cold. They do share values, and they do emit, regardless of who's listening. So they're hot, and there's a whole bunch of types of them. So I'm going to go over these real quick. The published one is the very first one, very commonly used. I pretty much only use the first two in realistic. You can see that the first two get turned into relays in just a moment. A published update is really good if you're observing something that you don't care about the past value. You just want to know when it happens. If you're, what's a good example? If you're like a button press, for example. You don't care when it was pressed before, you just want to know when it happened. So it doesn't take an initial value, and it doesn't replay past events. Behavior subject is a little bit different. This is an example if you're maybe watching a property, the UI text field is a text property. If you subscribe to it, you're probably going to want to know what that text was before you subscribe to it. So it is going to replay its value, and it does take initial value. And I'm going to skip down here before I get back to these two. Relays are special kinds of subjects that are located in the RxCocoa side of things. They don't emit errors that they don't complete. They only emit next. And that's really useful for UI because if you're subscribed to, for example, a UI text field as a text property, and maybe, actually in my example later I have a search bar where I'm listening to its text, and when the search bar changes its text, I hit an API request and I download some data based on that search query. If that errors, it's going to propagate the error back to the text observable, and when an error happens, we talked about it terminates, which means it would no longer propagate values for you anymore. Bad. That would basically break your logic there. So we don't want to do that. So for the UI related stuff, we pretty much always use relays if we're going to listen to UI because that way it won't propagate the errors back and it won't disconnect your logic. But there are certain types of subjects that you might want to use. Just wanted to throw them out there as options. Replays, if you do want to replay values, it doesn't take an initial property, but it does take an account for how big you want it to be when it makes values historically. Could be useful. I don't really know when you would use the last two, but they do exist. And the last one is an async subject. This is a little bit unique. And this is kind of what I was thinking when you talked about before, if you wanted to get like a history. Async subject is really weird. It internally might be emitting events, but you won't actually get them in your subscription until it finishes, and then you get the last one. So if it emits internally 10 values and then finishes, you only get the 10th value in your subscriber. Yeah, I struggle to know when I would use that personally, but you could just ignore the previous value maybe, but it's there.
Slot machine here?
Yeah, that, I guess like, maybe, again, to come back to text fields, if someone's changing their text field, you don't care about the values, you just care at the end what it's going to be before they submit it or something.
Maybe like a debounce type of thing, where you only get like the last one back.
Yeah, debounce is something useful. We'll talk about that too, for just, especially with the search bar thing.
Okay.
Yeah. But just know that it's a special type of class that can be observed and also observe other things. So they're really good for chaining things, especially if you reference like, I use the view model pattern a lot. If my UI has an observable property, like the text property of a text field, I might bind that to a subject in my view model. And then later in the view model, I can listen to the subject. So the subject essentially listens to the text, and I listen to the subject in the view model, and that way I kind of separate my logic. My view model doesn't know that the view controller exists, but by using a subject or something else like that, that kind of is an in-between link, I can still control that behavior. So another quick recap because I keep going really fast here. So observables, signals, computables, babies, all these traits that they call them, they emit events. That's the whole thing that they do. You listen to them by subscribing to them. You can share those emissions if you want to, without triggering the action multiple times. We talked about how you can call replay ref_count, which is just an alias to share, or you can call publish, that makes it a connectable observable, but you have to call connect_count to start. We have the whole hot versus cold thing, where do you want the events to be emitted when no one's listening, or do you want them to be silent if nothing's happening? If no one's listening to them, you know, does it, when a tree falls in the forest kind of thing. And then subjects and relays, observables that can also observe. If you look online at subjects and relays, there's a hot topic on whether or not you should ever use them. I keep finding use cases for them, but I struggle to define them. Pretty much only the view model thing I talked about, where I'm kind of linking two unrelated chains of data. That's when I might use them, but some people say you never should. Operators. Okay, so here's where we get to the actual using them. So everything up to this point has been creating the block that does the logic. What do we do with it after that? We want them to be composable, we want them to be functional. Here's where we get to that. There are a ton of operators. I mean, there's literally like 100 of them. So I'm not going to go through all of them. There is a really great reference here, though. I will click on this really quick because it's kind of cool. That's hard to see. That's awesome.
So that's snarky.
Alright, so this is hey, here you go. I got a slide out there. There's a ton of them. There's a ton of them.
There's way 200 pounds of these.
And at the end, they have a decision tree where if you want to do something, you can kind of follow this thing and it'll tell you which one you want to do. And this is a huge goddamn tree. Wow. So there are a lot of them. That is the whole point of this diversion here. Is there is an operator for every use case. Not there yet. There's a couple of broad categories. This isn't all of them, but generally speaking, the observables or any kind of block of logic, you might want to transform them, filter them, combine them. There's some utility ones that include like subscribing to them or only waiting until you get the last value or something. Some conditional stuff, if you just want to maybe aggregate the results, to get in the first, to count the emission or something like that. I think that's aggregate too. Anyway, conditional is like filtering, I think. Or I said that too. I don't know. There's a lot. Don't worry too much about which one specifically, but Marble diagram, because Pat just said, spoiling my bigger bill here. This crazy looking thing annoyed the hell out of me for years until I finally figured out how they work and what they really mean. So I'm going to try to summarize it and then show you an even better resource than me right on the side there. So this right here is your input. And these little shapes represent emissions, the on-next thing getting called in your subscription, or in your report. And here's the output. And this is the operator. So in this case, the flip operator takes red star and makes it upside down red star. So this line is the event going through the transform to the output.
I can't say about the circle being
Oh, I'll get it. Circles like being flipped. It throws an X, which represents an error.
Yes.
So you can't flip a circle, like you can flip a circle. In this example, it doesn't know how to do that, so it breaks. It is a timeline, it does go left or right. This bar means that it's complete. This is not really useful when you have just one input, but if you're composing two inputs and seeing when they complete is very useful. This style of marble diagram is used for literally every one of those gazillions of operators I talked about. And I found a really good resource. It's actually used for RxJS and the JavaScript stuff, but remember the APIs. There we go. The operators are pretty much the exact same across platforms, so it doesn't really matter. Because they're named the same thing, they do the same thing. So if we take this example here, this is the merge operator. We see we have two inputs, and here's the output pod. So you can kind of just see what they're looking at, but it doesn't do anything other than just whenever one of them emits, it just passes it along. So what's kind of cool about this is you can drag these around and play with it a little bit, which is kind of neat. So if I take like a different operator, like merge, this is merge, in my case, this is kind of neat. So there's two inputs here. And when the first one emits a 1, we don't do anything. It waits till the second one emits a value, and then the closure, this is JavaScript, but you can imagine this would be, so it's just literally concatenate as strings, it emits 1A. And then a 2 comes next, and it becomes 2A, because it's the latest of each of the streams. And then there's 2B. And if I move this over here, we're going to get 1B, because it comes before 2. So you can kind of, it makes it a little bit easier to understand what these do.
What's this website?
RX Marbles. Yeah, crazy, right?
That's awesome.
Yeah.
That would help me so much.
It doesn't have all of them.
that'd be very useful right there.
It doesn't have all of them, but it does have a lot of them. It also has some that don't exist in RxSwift because it centers RxJS. Pretty cool though. So, if you're ever trying to figure out how to do a certain thing, look up the marble diagram, and maybe you can find a little bit of explanation on what it does. And you can always use the flowchart in the previous web page to figure out which operator you actually want to use. Here's a couple of notable ones. FlatMap is a big thing because this is really how you're changing your operations. And we already have FlatMap in Swift, so we're kind of familiar with it, which is kind of nice. But it takes your event, so your observable emits an event, and a FlatMap returns a different observable for one of the traits that are observable. And that's really great because if you, for example, log in, and so you return like a user object. From the user object, you want to download their favorite movies or something like that. You would take that user property and pass its ID into a different function, which returns a different observable. You can keep chaining them along like that. So FlatMap is great for that. There's a couple of variations on FlatMap we'll talk about later, but that's the main way we're going to compose. The main way we're going to change these operations. Merge, we just saw as an example. We have multiple streams. It doesn't have to be two, it can be more than two. It can be any number of them. I think it takes a var. It's just going to emit all their values to some merged thing, which could be useful in some cases. Combined latest, we showed you that one too. Whatever the latest value is of however many streams, and then you give it a closure to tell it how to combine these two, because they don't have to be the same type. In the example we saw, they had one integer and one strings. Your logic will dictate what you do with them. In the example we saw, they just combined them as a string, because that makes it very easy to see. But it could be anything. Zip, we mentioned like that before, is just like combined latest, except it waits for each stream to emit a new value to pair them before it emits anything. So the difference being with combined latest, if the first stream emits one, second stream emits one, and the first one emits one again, it's not going to emit a new value to your output until the second one emits one. It has to wait until each one of your inputs emits something. And distinction proteins, last time I talked about, is really useful, especially if you go back to the whole search bar thing, because that's my example at the end. If you are listening to events, sometimes you don't want duplicates. Sometimes if you're watching text, for example, you really only want to know when they change it. If they don't change, then it's kind of redundant for you to do anything with it, sometimes. And so distinct proteins can do that, especially paired up with debounce, which would make it wait a little bit before actually firing. Very useful.
Yeah. So, as an example use case, say you have like your user, and you're making like 3 separate network calls, like get a profile picture, likes, and like some other thing, and you don't want to reload your view until all those 3 things are complete. Is that zip or is that merge?
There's a couple ways you can do that. So I think what comes to mind immediately, so you would have your first observable, which is the login, and then you would say FlatMap, so you have your user model, or whatever you get back from the login result. And from in this closure, where you're provided the user, you need to return an observable that does whatever you want. So in your case, it does 3 different things. So you would, in that closure, make the 3 observables and then probably merge them, or not, actually probably not. Zip would be a good example if you want them all to wait to the end. Yeah, if you want to be the end, you would do zip. I was thinking if you want to maybe do combined latest, if you want to do like a progress or something like that.
I think you always want to use zip if you expect them to get the same number of results. Like you're making 3 requests, they're all going to each get 1 result, and so you can zip them together. Now, if one of them is a subscription, maybe you're subscribing to like a chat feed or something, that's going to continue to emit events and the other 2 aren't. And so the zip is not going to emit, it has to get an event from each one and output it. So you're right, I think you said zip.
And it works fine with like heterogeneous types, like, on next it will, like, next it will have different types in each one.
Yeah, because the way the closure works, I guess it's whatever generics are the types of observables you pass into it, that generic becomes the property in the closure, if that makes any sense. So it doesn't matter what type you pass into it, it's just gonna, whatever the return type is of each of those observables will be inputs in your closure that combines them somehow.
So that'll get transformed into a tuple or something.
Exactly. Yeah.
Zip makes a tuple.
There's a FlatMap. If you you do like 2 or 3 of them, are they done in order, or do you have to use something else to keep the order accurate? One is dependent on the result of the one before it.
So, I want to make sure I understand, because there's a couple ways I can answer this, I think. Remember that every time an observable emits an event, it's going to call whatever things happen after any operators. So, if, for example, you have a network request that only emits one value, and you have flat under it, you can rest assured it's only going to happen once. But if, for example, you have chat message stream, where it might happen multiple times, you might be flat mapping to do different things multiple times. And if you want to be sure of the order there, I think there are operators for that. I think would concat be the right one?
I don't know. Generally with flat map, it's like always a one thing after the other, and they're going to happen in the order that you see them written. And so you have one observable, you get an event, that creates another one, you wait for that to finish, and that creates another one. So the flat map is generally like linear.
You're going to run it. So this is one thing I was thinking of here. See how in this example, it takes the first input and it waits until it completes before it emits any of the second ones. So that's one way of doing it.
That's interesting.
Yeah, I know that exists either, but I went through most of these so I could learn
That's
this.
it. Yeah, a lot of them are kind of like rarely used unless you have like very specific like.
Yeah. And that's why it's one of those things. The more I research Rx, the more it seems kind of like a hammer and everything's a nail. Like I think I can use it to solve everything. I'm torn on whether or not that's a good idea because it feels like I'm putting all my eggs in one basket.
Because you may realize like, I don't care if these, I don't care what order they finish. When I get this thing, like when I get the profile picture, I did that. When I get the other thing, I did that. It's like, it doesn't usually matter. But
And one of the good things about the whole Rx thing too is like you can be kind of embedded in that ecosystem, but if you want to step out into using non-Rx stuff, you totally can. You can go back into it later. They discourage that because you might make errors along the way if you don't do it in the official way or whatever, but if you decide you just want to use Rx for network requests and then use everything else the way you're used to, there's nothing wrong with that. It's basically the exact same thing you do with the current implementation, whether it's Allen Flyer or NCURL session or whatever. It's really up to you. But it does try to let you be flexible. It doesn't try to trap you into its system if you're not comfortable with it, or if you have a use case where you don't know how to do it the Rx way, you can go back to however you're comfortable with it. Oh, I have more examples. Great. Glad I put these in here because I forget. Go to the top here. So, a couple examples of operators, which I guess I should have done sharing descriptions for. We're going to go here. A lot. This is a bit backward. Yeah, let's go back. Traits. Remember, traits are the different types of observables. So here, at the beginning, I've created a single, which has a create block. And notice it's a little bit different because instead of getting an observer here, they don't give you that, they give you an event. And an event is actually a closure that takes in a single event and returns void. So in order to actually propagate an event here, or actually, you pass the instance of the enum. For singles, it's got two cases, success and failure. So in this example here, I create a single of type integer. I say it worked with a 3, and I say create with nothing in there, because there's nothing to actually dispose of. And then I subscribe to it here, and you can see it says success 3. Pretty simple. Let's give you an example of what you do wrong. So remember, singles emit one event, and that's it. So I made a little error thing, it's one case. What happens if I call 2 success cases? I thought it would crash. It doesn't. It just emits one of them. That's nice. I did see later, if you take an observable, if you make an observable, you can actually call to single or as single on it, and it'll convert to single for you. If in that observable you don't emit just one value, it will return an error that says sequence gave the wrong number of results. So you have to be very careful when you choose to use these, but if you do them right, you just have a cleaner bit of interface to know what to expect. So, success error only propagates the first one. That's the takeaway there. And completable is next. Very simple here. We make completable. I call completed. Very happy. Notice that there's no generic type here. It doesn't actually return any object. It just says I'm done, and then it works. And the last one with maybe just use a non-integer, non-string to be different. Just CT rect. And I immediately call it error because I'm not happy. And it says says error. Notice that maybe didn't return anything, that's perfectly valid, and maybe did not, because it can return 0 or 1 results. If I had tried to return 2, it wouldn't have worked, or rather it would have just returned the first one, because the 3 cases for maybe are success, error, and completed. So maybe it's kind of in between the single and observable. Like I said, I don't really know when you choose to use maybe. I think it's one of those things that might be forced to use in some cases. But yeah, same thing here. I chose an example of a bad maybe. If you try to succeed and then error, it's just going to print a success because that's a terminating event for a maybe. So if you try to do that, it's just not going to work. Subjects, one of the more fun ones, if you ask me. Much easier to read too. Take a subject. Published subjects don't take initial values and they don't propagate past results when you subscribe to them. So here, I immediately add a value to it. Now remember, these are both observables and can be observed. So because it's an observable, or rather it can be observed, I call on next, I say too early, never gets printed because I subscribe after this has happened. So once I subscribe to it, I say hello world and then complete, and then I call too late after I complete it. It's not going to emit it. It just carries, once it completes or errors, no more. Behavior subject is the next one. It's very similar, except it does take an initial input and it does propagate past events. So in this example, with an integer type, I start with 100, I say next 200, I subscribe, and notice that 200 gets printed first because it's going to immediately give you the past result. Then I say next 400, then I say completed, and then I say next 0. And it's going to say 400 is completed, and totally ignore the 0 because it happened after it was terminated. Two use cases there. Definitely, it just depends on what you're listening to as to which one you want to use. Sharing. So the first one here is just an integer, and I specifically crafted this. I could have used the from method to make an array that's just going to end in 1, 2, 3, but I specifically used create because I'm never actually emitting complete. So this thing's going to keep going and going and going. It's never actually going to terminate itself unless I dispose of its observable, or rather a subscription to it, which I don't do yet. So either way, I subscribe to it here, and I have different prints for next, error, completed, and disposed. And you can see here that it prints out 1, 2, 3 because I tell it to. But it doesn't call complete and doesn't call disposed. So below here, I subscribe to it again. And I get 1, 2, 3 again. It happened again. It didn't share anything with me, it just did it all over again because I didn't use any of my sharing methods that we talked about. So let's do that. So I have my previous int observable, and I call share with a replay of 1 on it. Now I call subscribe on my sharing one, and I'm deliberately making the disposable here because I want to handle it later. So it's going to print out 1, 2, 3. Okay, that makes sense. Let's do it again. We're going to listen to that same int observable. We're going to subscribe to it. Uh-oh. Or not uh-oh. It's only going to print 3 because it's getting the last value, and I gave it a share replay value of 1. So it's sharing its results there. It's not actually going through the create block.
Where did you get the shared valuable?
Right, there. Good. Sorry, so I don't have enough screen notification. I think let's get rid of the bottom thing. We're not actually using that. So that's why that just returns 3. Interestingly here, then I decided to dispose of them. So at first I dispose of 1. And it says dispose 1, because up above you can't see it, but I told it to dispose 1 to print that. Then when I call dispose 2, it disposes of the actual observable. And this print statement is actually located way up when I started, right here. So when we dispose of it, we call disposing observable. And it only disposes of it when the last one, the last subscriber, decides he wants to dispose of it. It wouldn't have done it if I hadn't called dispose 2. So it can be useful if you want to keep something alive for a little bit and just make sure that one person is listening to it. If you don't want to make sure one person is listening to it, use one of the other ways of doing it, like making it calling publish to make it connectable. But I figured that would be a good enough small example where we go to operators. Okay, back to the thing. Beginning observable, 1, 2, 3. It's all it's going to emit, very simple. Map. We've all used map probably, which is regular Swift collections. It does the same thing here. So in this example, I'm saying, okay, take my input value, multiply it by 10, turn it into a string. Okay, so 1, 2, 3 becomes 10, 20, 30. And then complete it. Math's pretty simple, but you do have at your disposal and it's very useful. Flat math. Flat math's a little bit weird when I'm trying to do this in a synchronous way, because you typically wouldn't do that. But like I mentioned, asynchronous stuff's a little bit tricky in the playground, so I just want to demonstrate what you can do, maybe not why you do this stuff. In this example, for every addition to the flat map, we're going to return a different array that has 3 values. The value times 5, 7, and 11. And I've chosen prime specifically so you can see them down here. So remember, our initial observable here returns 1, 2, 3. And then we're going to multiply them by 5, 7, and 11. So notice over here we get 5, and then that's 1 times 5, 1 times 7, and then 10. That's 2 times 5. And then we have 1 times 11. Like, the order gets a little bit weird here. This could be a problem. Remember I talked about with, let's say you are doing the search bar thing where someone starts typing, and when they stop typing after a half second, you take that text and you make an API call and you filter some stuff from an API and you send it back down. Well, let's say while they're typing, or rather while you're waiting, they keep typing. They type something new. And so before the last request is finished, you fire off a new request. And then that last request finishes, and your UI updates with stale data. That's bad, which is what would happen if you just use regular flat map. But there's a better way, called flat map latest, which is what you typically want to use in these scenarios where you have multiple emissions. So in this example, remember our original observable just emits 1, 2, 3, and we're doing the same thing over here where we're multiplying it by 5, 7, and 11 into an array. So our results, the number 1 comes in, and it prints out 5, because 5 is the first event that's going to be emitted from our secondary observable there. Let me move this down, so you can actually see it. Cool. And then 10, so 2 is the next number that's going to be emitted from the original one. It's going to be multiplied by the first value here, we're going to get 10. Notice it stopped caring about the remaining emissions from the first value pushed into here. The 1, we don't care anymore because a new value, the 2, came in, and we only care about the latest one. So then 3 comes in, so we get 15. Well, there's no more emissions from the first observable, so it's going to keep printing up 3 times 7 is 21, 3 times 11 is 33. So that can be useful if you're trying to make sure that you only get the latest results whenever you have multiple emissions happening. It's like location updates or chat requests or something like that where you have a stream of data.
So I have a question. If you scroll back up to the first flat map.
Yeah.
So we get the first value, the 1, and we do the first 2 multiplications, and then we get the second value, which is 3, or sorry.
Yeah, you get the first and the
You
second.
get the 2, yeah, sorry, you get the 2, and then it does 2 times 5. It's really weird to me that it doesn't let these multiplications finish before it emits like the second value. Like, why does it get out of order there? Is that just like implementation defined kind of inside of?
I think it is, and actually, you kind of see the same behavior. If I go back to the sharing at the very end here, notice that when I dispose of 2, the first thing it does is it actually disposes of the whole observable before it disposes of the subscriber. I wouldn't expect that. I would expect the subscriber to go away first, but it doesn't.
Okay.
So I think that's kind of the same logic here. If you think about it in terms of, this is the first thing to be emitted, then the second, this is actually the third.
Okay.
This is kind of emitted at the same time, but for some reason it gets emitted first. The next one after this is this, which would normally then be this, but this gets emitted first because these kind of happen at the same time. It's a weird implementation.
Yeah, especially, I would just, because these are like synchronous, and we're not waiting on anything to finish, I would just expect them to be all in the right order, so.
Me too.
I probably have more stuff I have to do things.
Yeah, again, it's not common for you to use flat map on synchronous arrays. This is a really obscure implementation that just needs something really simple to demonstrate.
It seems like there's just a delay between each consideration and multiple ones. That's why we're getting that.
Yeah, something's going on there where it's like interweaves.
Yeah, good observation. I definitely noticed that too, and I had a guess, but I didn't dig into why.
Like, they may have a background thread where they're doing some of the coordinating and it like interrupts this thread to like put stuff out, you know what I'm saying?
I'm going to talk about threading in a little bit. By default, these all run on the current playground's gonna be different.
Okay.
But in your normal application, whichever thread called subscribe, that's what it's gonna run on. So all of these, because we're not specifying any different threads, and these are all the kind of base level observables, they should all be happening on the current thread. There shouldn't be any.
But see, that's what I would think, but like you're getting out of order because it's something weird stuff.
Yeah,
That's interesting. I'm glad you showed that because I wouldn't expect that.
I could just post this on the issues of their GitHub page and see if they have a good reason for it. It does seem like it's unexpected, but it is consistent. So, good point though. Merge. Really simple. I have two arrays of strings. Uno, dos, tres, 1, 2, 3. You call merge, and it just prints them out. Iterate 1, 2, 3, 4, 5, 6. And complete it. Submitted all of them. Pretty straightforward. And then a zip example where I have different types. So I have an array of integers and an array of strings. And when you call zip on them, it automatically knows one's an int and one's a string in that tuple there. So that's kind of nice, and then I just turn it into a combined string. I forgot to print this. I might have done most of this last night.
Stretch.
I started it 10 days ago, and then I got lazy. Using the zip example, it prints out next for 100 in Cocoa, because it's combining these two, and then 200 in heads, these two, and then nothing more, because there's two more values here, but they don't have a matched pair in the second observable. So if you're zipping them, we're only going to get 2 emissions before it completes. Okay, I think that's back to this. Getting backgrounds. Schedulers, we just talked about threading. This is how you handle that for observables. Schedulers, there are 2 methods on your observables that handle this. There's subscribe on and observe on. So subscribe on says you're going to pass a scheduler to it, and it's going to run your initial observable on that scheduler. Schedulers are things like current thread, dispatch queue, operation queue, some other thread pools, run loop. You get to specify. And I'm going to talk on the next slide which examples you're getting for free, and you can make your own, though I have no idea how to do that or what I would want to do differently than the default, but you can. And observe on is a little bit different. So this one will affect the first observable, first action. This said whenever you call observe on, anything after that will be on this thread. And if you don't call either one of them, it's going to just run on whichever thread you call subscribe on. Or not this subscribe on, but you call the subscribe method on that given thread. That makes any sense. If you don't call any of these, it's whatever thread you're on when you call the action, that's the thread that's going to get returned on. So it's entirely possible that in your stream of logic, you might have multiple observe on methods. If, for example, you want to take data from the UI, which is on the main thread, pass it to a background thread, compute it, pass it to a different computation thread to store it in the database, come back to the main thread to update your UI, you would have probably multiple different observe-ons interleaved between your flat maps. So totally valid. Some of the schedulers we're getting for free. Current thread scheduler, that's what it starts on by default. Main scheduler is obviously very useful. That's what's going to go to the main thread. So then you have 2 dispatch queue ones where things take in a dispatch queue, and then an operation queue scheduler, which is really useful because if you want to maximize how many concurrent operations you have, you're going to use that one because you pass it an operation queue and you define that max concurrent operation count on the operation queue before you pass the scheduler that you then pass to your observable. Side effects. I think this is the last one I have before we go to RxCocoa. Use sparingly because these are, well, just the word side effect should give you like a little bit of a chill in your programming. Sometimes things happen, or things that you want to happen, but you don't really want to observe you don't want to consume the observable. You just kind of want to be notified when something happens. Maybe, for example, you want to be notified when your network request gets subscribed to, because you know that's going to kick it off and show a loading spinner. And then when it's disposed, you would hide the loading spinner. Or for analytic purposes, you might want to say something error. So you would say on error, analytic manager, or something. It's not going to consume the event. You don't have to return anything, but you can hear about it. So that's what these do here. I say use sparingly. The guys don't say that. I say that because I feel like that's just weird. The examples I saw online I disagreed with. Some of them said, for example, you have a network request and you want to save data to like a database, you might do a side effect for that. I think that's a bad idea because that could fail. If any of these operations could fail, you don't want to put them in the do. These are called do methods. That's the do on there, do on error, do on completed. You don't want to put it there because that error wouldn't go anywhere. So you probably want to know if that you couldn't save your database. And so if normally you would then chain that as a flat match operation, not as a side effect. But there could be reasons you want to do that, like I said, for analytics purposes, or if you just want to log. Debugging is actually really useful, but in production, I'm not easy about it. Quick recap again. So a lot of information I told you, I'm trying to cover a wide range of topics without giving you a whole lot of depth into any of them for time constraints. Observables, big main thing, have the logic. You listen to them through subscriptions. There are lots of different types of observables based on what you expect your logic to return, how many emissions you want. Subjects and relays can be both an observer and an observable. They are hot, which means that they're going to be emitting regardless of anyone's listening. You can transform and filter and modify all of your observables with different operators. I showed you guys that huge list of them, but like mapping on them, filtering, things like that. We can control the threading behavior, so if you want to make sure that different operations, different bits of logic happen on different threads, you have complete control over that too. And lastly, side effects, if you want to know when something errored without actually consuming that error, so that it can get propagated to your actual interface. For example, if you want to show an error message, you can do that. And that way your view controller doesn't have to have your analytics code that can be in your view model, for example. Excuse me. Okay, RxCocoa. I promise it's like 3 slides here and then we're done. The traits are probably the only important thing about this, because everything else in RxCocoa I've kind of already talked about. It's really the same principles of RxSwift just applied to Cocoa stuff. But there are a couple of distinctions here. So remember how I talked about if you're listening to the text property or text field or a button press or some UI thing, and chained to that listener you have some operation which can fail or complete, and it propagates back up the chain, it's going to disconnect, it's going to turn off those listeners to those UI elements, which is bad. So we never want to propagate completions or errors up the chain, which is exactly where driver and signal come in here. So drivers, same thing as an observable, but they don't error and they don't complete. Also, they're always in the main thread. So if you take an observable and you say as driver, it's going to basically call observe on main scheduler.instance for you. You just won't see it, but it only works in the main thread. If you were to say actually you probably can't even change the observe on as a driver. I probably don't even expose that for you. Drivers are a little bit special too. They do replay the last event when you subscribe to them, which is how they differ from Signal. Signal does not. Why do we care about that? Because when it comes to UI, there's really 2 types of observations, properties and events. Property would be like text, or maybe like slider, some kind of some quantifiable value that you're getting from your UI, as opposed to a button press, a scroll. That would be an event. If it's quantifiable, we probably want it to pass value when you subscribe to it. So control property, same thing as a driver, basically. But it does complete if the control gets allocated. That's the difference here, because these are directly related to UI elements. If the UI element goes away, so do these, is what would they be listening to. In fact, that would probably cause memory leak if they didn't dispose of that. So binding, I think, is probably the last important thing here. So this is how we kind of map our observables, our listeners to the UI. There's a method on observable called bind, where you can pass in an observer to it, and it will propagate the values to that listener. It's not the same as calling subscribe. I have an example. I'm doing a bad job of explaining it. I have an actual example which will be easier to understand. But basically, it propagates the changes of those events or properties to your listener, which can then be propagated further. This is kind of how we get away with really short code, because we don't typically call subscribe as much as you would think. A lot of the time we just bind directly, because we know that if we have, for example, your title in your navigation bar, that is a bindable thing. You can bind to that. So if you have an observable of type string, you can bind that observable to the title of your navigation item. You never have to manually say subscribe on next title equals new value. It'll do it for you. So that's kind of the crux here, is just eliminating that subscribe for you. naturally when you find it doesn't turn the server a disposable because it's substituting the subscription. You do have to handle that. Oh, and the last thing here is that we have bindings for signals and drivers too, but they call them emit and drive respectively. I read the docs on this. They really just wanted to change how you read it, like in English, but it does the exact same thing. It's like the data from the driver drives the UI, as opposed to bindings. I guess it's not good enough for them. Demo app. Finally, fun part. So I have a very simple, very ugly application that I made. I'm going to run it before I actually show you the code for it. Oh, that's a fail. We're in very
Yeah, so we did actually install. Now you have to do this with 5 upgrade.
Would you like to install?
No, actually, what?
You have to close on Teams.
Okay, so this application, there's an online, I just wanted to take any API online and have some kind of searchable thing. That's what I keep going back to here. I found one called OMDB. I think it just is like an API, kind of like IMDb, but it's RAS. It's
Operas, right?
What's that? Oh, it's got a lot of weird crap. I gotta be very careful what I search if you know what I mean. So I found that the wrong way the first time I searched it. So all I'm gonna do here, this code is really simple. I'm just gonna search text in here. So let's pick a nice generic word like movie. And then it's going to get the first 10 movies from that API and put them here. That's it. That's all it does. I can't go down. It doesn't do anything. I really want to show you that if I change it, if I delete, it waits a half a second and then finds the movie. It's apparently their API is matching exactly on that word. It's not. It doesn't do a like comparison. So it's pretty good. Yeah, it's apparently good internet here. It's the same thing, you know, if like what's the
Yeah, it's only because there's nobody here right now.
So it's really simple, right? So let's see how we actually do this, because it is shockingly little code. And that is the whole point of it. I know that's a really small, ugly example. So I don't use storyboards because I like to control the initializers for my storyboards. So I'm going to start at the very beginning here, because I've only got like 5 files, 6 files, counting app delegate. Alright, so the first thing I'm going to do is you need to have the API key. So this is my README and the GitHub thing, but yeah, if you plan to pull this down and try it, you need the API key. It's free. You do have to like sign up for it. You do have to email it to you, but it's free. So I'm making a network manager. This is really boring. All it really does is just takes the API key, builds the URL, and spits it out here. So remember that snippet I showed you where we make the data emission for URL sessions. So session here is just a private, or is a property of my network manager. I call Rx to get access to the Rx properties. I call data during a URL request. That returns an observable type of data. But I don't want data. I want my media search result model object that I declared. So I mapped it because I'm turning data into this. So I have a decoder that I have as part of this class here. Turn it into that. I'm using codable shorthand. Note that I call try, and I don't question mark and everything like that, because if this fails, it's going to just turn this into throwing an error, because it's already going to do that. Like this essentially has like an implicit throws wrap on it, so it's good. And then I call that single because I get mad when this is a network request and not a single. I was going to write my own wrapper on it, but I figured I really want to show you what you can do out of the box, so I didn't do that. But I made it as a single. That's all you have to do. And all this does here by calling as single is that whenever it gets the first result, it's going to be like, okay, I'm good. And if it gets a second result, it's going to throw an error instead. So be careful with that. That's why it's good to wrap it yourself and do it yourself. But trying to use your out-of-the-box stuff. So great. Network manager, TLDR, it's a network request. There's nothing jazzy about it. It just returns it as an observable. View model. I pass the network manager to it. I really like dependency injection, as you can see here, so I keep making my stuff and not doing singletons. View model does exactly what you think. I make a view controller, pass the view model to it. I put it in an app controller because I can, and then I make that the root view controller and show it. Great. Nothing really fancy here. Let's start with the view controller. So I define all the UI in code. That's really boring. Let's start here. So view did load, set up UI, I have a table view in a search bar, make some constraints on it. That's it. So let's talk about what we have to do here. I have a search bar and I have a table view. I want to listen to the search bar to get the text, and then I want to take that text and pass it to my view model. I'll get to that next. And then from the view model, I want to wait until I get new data, and then update my table view with it. So, spoiler, one thing I didn't do when making my properties up here, I didn't make myself the data source of my table view. Don't need to. because we configure bindings here. This is it. This is the whole thing that does everything I just said here. So we have our search bar. We call Rx, we get access to the Rx function, we call it text. Now remember, text is actually an optional string property on most of these UI elements. So we call it or empty afterward, which just means that if it's optional, it returns an empty string instead. And then we bind it to the view model's search. What is search? I'll go there in a second. And then we add it to a dispose tag. So internally here, I have a dispose tag at the top, and it's very important when the dispose tag gets deallocated because the view controller goes away, it'll clean this up for me. Same thing here. ViewModel.media, this is what's returning my actual media content, the movies or TV shows. I call it drive. It's a driver type. And it's a really cool thing with table view, Rx items. And you can't read it, too much text. You can see most of it. It actually wraps around down here. You give it a cell identifier, it gives you something, I think it's an index, which I always store because I don't need it. The object, media, and the cell itself, and then I say cell.textlabel.text equals media.title. That's just the model object. You can trust me that that works. And then we add it to the dispose tag. So the next question you probably think is, well, that's not much code, but what is viewModel.search? What is viewModel.media? So there's a couple ways I could have done this, and I chose to do it a little more complicated because I think it's cleaner. So this is the whole view model, right here. Very short. So we pass in our network manager and I make search subject. And you might be thinking, okay, why are we doing a subject? Well, really, remember that with the search bar, I'm listening to the search bar, and then from that search bar, I want to do more stuff. So in my edit here, I say, okay, the search bar is going to be my search subject as an observer, meaning my search subject is observing search. Search being the search bar is text or anything we talked about. And then media, you're going to take that search subject and it's going to wait for events to fire. And it's first going to debounce them on the main thread. It's going to wait a half a second. And what debounce means, if you're not familiar, it's basically as soon as we get an event, it's going to put a timer up for a half a second and wait. And if another event comes within that half a second, it's going to restart the timer. It's going to wait until we don't get a new event for a half a second. And when that finally happens, we're going to say distinct until changed. Because if, for example, I type the letter and then I backspaced it, I don't need to refresh anything, nothing changed. So it's not going to do anything. But if it did change, it's going to call flatten map latest, and it's going to call fetch media with the query string we passed in that we got from the search subject that we got from the search bar. It's all coming together here. Then I map it because the result actually gives me like one of the boring API things where it's like, here's your data, here's the count, boring stuff. Really, I just want this right here is an array of the movies themselves. And then I did something I'm not super happy about, and I'm trying to find a better way. I don't want this to ever error. And I was having problems with my network, and it was basically erroring because it couldn't connect. And so I added here catch error, just return an empty array. And so what I'm doing here is if for some reason I can't decode it, or the server is down, or my internet's broken, or like your phone's just glitched, it's going to return an empty array instead of actually propagating that error up. Which again is useful because if I don't do that, then my table is never going to get any stuff because I'm going to stop listening to it. Or more importantly, I'm going to stop listening to the search bar because it's a search icon. You're keeping it on. Pretty much, yeah. And then the last thing I do here is I say as driver. And one of the things about the driver, remember, they can't emit errors. So one of the conditions of turning an observable to a driver, you have to tell it what it would do if it did error. And again, it's the same code you return an empty array. I want to find a way to like do that just once, but I couldn't find it because technically flatmap latest doesn't return single. It actually returns an observable. And I can't specify it to return whatever the return type is of the closure unless I would write one myself. But I didn't want to do that. And that's it. That's the whole code. So there's just like 6-7 lines in the view controller and like 8 lines in the view model. And we can listen to changes in the text field, or search bar rather, hit an API request, get the data, make sure that it's good, pass it back, populate a table view. That's it. So that's the sample project. It's like 2 slides left. Is there any questions about that before I finish this up? Cool. So what else is there? So that's pretty much, like I said, I've tried to give you guys a big, broad, like, wow, I could use Rx for this, or maybe this or that, but you're probably still going to have to do your homework to really understand how to do it. Fortunately, there is a repo RxSwift community. They've already done a lot of the heavy lifting for us. So if you, for example, use Allen Fire or Firebase, Or you want to get notifications using Rx for like when the keyboard shows or hides. Or a really cool one I've been using is a bidirectional thing with relays, where in my view model, I don't like exposing relays, so I could avoid it, because that's the whole reason I didn't expose the subject before, because to expose the subject and your view controller can technically emit events to your view model, which is bad, you know, for like encapsulation reasons. But anywho, bidirectional binding is pretty cool because if, for example, you had an edit profile screen where they have their name and your view model gets populated, and you say, okay, my view model name equals blank, and bam, it'll just automatically fill that label or that text field for you, and then the text field updates, bam, it updates your view model for you. That kind of bidirectional thing, there's a library for that, there's an operator for it. So, lots of stuff already done, there's probably like 50 different libraries contained here. Really useful. This is a cool thing I've been following. So this is a crazy guide for Rx, model view, view model coordinator, pattern, and code. Basically handling everything from your navigation to your data management, like everything in your application with Rx. So if you wanted like a really advanced, like pound your head against the wall and wonder why would you do this, go read that. It's pretty cool. I actually like it, but it's definitely I would scare away any junior I showed that to, and that's why I don't use it at work. So I think I have, no, that's it. Thank you guys for coming out here. This has been awesome. Thank you guys again for organizing it. I know that was a lot. I hope that didn't scare you off of Rx instead of making you want to try.
I think a footprint is the standard framework.
Good question. I have no idea. I don't think it's colossal, but it's probably something.
Yeah, there's a fair number of like, you know, different traits and things like single and all the operators and stuff. And you're probably only going to use a small subset of them, so it's, you know, it's fairly large for what you're going to use.
Yeah, and that's how you would add it too.
Yeah, so.
They have special testing frameworks. I didn't cover testing because one, I haven't done it, but they do have special Rx test and Rx blocking, I think, that you would add to your test target, and you can, you know, test.
That's what I was gonna ask, like how easy can be found to like be able to use.
So I sadly did not do a whole lot of testing. My last job, we never did it. In my current job, I just haven't done enough Rx to warrant it. Apparently it's fairly easy, but I can't really vouch for it because I haven't done it.
I think basically like your test could take one of your observables and subscribe to it, just like a normal async test where you have the expectation and then you wait for it and you check the result, which is like going to be a fair amount of boilerplate in each test, and they probably have stuff to like handle all that like under the RxSwift framework.
Yeah, and if you go to like the RxSwift page, they have a whole documentation list of like 20 different articles within the GitHub stuff. They have a thing on testing, but this was already really long and I didn't want to talk about something I knew nothing about. Anyway, so good idea to definitely use testing. It's definitely possible, but I haven't done it.
Have you found yourself wrapping RxSwift or using it just straight up like as bare? Yeah.
So one thing I did that was kind of neat that I felt proud of is using the whole binding thing, which I think is really neat because that kind of minimizes your code. For example, loading spinners. I wanted to have a Boolean property, so like in my view model, that when I flip it to yes or no, I show or hide a spinner. So I was like, okay, how can I do this like the minimal way? And you can basically define a binder property as like an extension on the reactor class. So you would say, because you know from before in my slides, it said like extension reactor where base colon class. That's like how they do it. I think they must make NS object extend reactor or something. I don't know how they get it to every object, but that's how you get it to specifically that type. And so in my example, I had used SD Progress Hub, one of those many libraries out there, and I added an reactor extension to it that was a binder property on that Boolean. And in there, you can define a closure, and it says, okay, if the Boolean is this, do this, if it's false, do this. Like it's just a closure. You're given a Boolean, so do what you want with it. And I was able to say hide or show this based on it. And so given that, I was able to bind it to my view model when something happens in the, I think it was actually in the side effects, which I don't agree with, but I did this because I was trying it. I would set that property. I would pass a new value to that Boolean, which would update the spinner's binding, which is kind of cool. So to answer the question, like how to build on stuff is just being out of the box. Mostly out of the box, but there are times where I want to try something that's either new or isn't supported by it. Sometimes I don't like bringing in libraries if I can avoid it. Like for Albumfire, for example, in the project I was using, I was actually using Albumfire. Solely using, if anyone here has ever done like image uploading using SERVPRO session, it's crazy syntax. Like, anyone tried that? It's so ugly. It's all that. Yeah, that's a crazy string manipulation operation. It's like, it's ridiculous. I digress. That's the reason I use Albumfire. If I have a project where I know I have to upload images, I use Albumfire. It's probably a bad thing. I should probably just use it for that one use case. But anywho, in that example, I basically just did the same code that I showed you for the URL session, and I just wrapped the Albumfire thing for it. So I didn't use Albumfire. I just did my own thing. But so, it's kind of your choice on like do you trust third party or not, or do you want to try it yourself. Normally I want to try it myself, but for example, the keyboard changes. I can't stand running that stupid notification every time I want to get like an update on that. And it's really easy because it just has it's an observable that I think returns like a CG rect, and it shows you like the rectangle position of the keyboard, and with that you can manipulate stuff. You lose a little bit of like the details. Normally when you subscribe to that, you get like the animation type and duration. They don't do that, but by default, it's still pretty cool.
And how have you found like debugging? Like so far, I don't know if it's like RxCocoa like helps out a little bit with that. But.
So debug can be a huge pain in the ass with this one. If you look at the stack traces, it's kind of gnarly. Actually, let me do that real quick.
Yeah, because you get all the internal like Rx machinery and those sections.
Put a breakpoint right here. And we'll just search vendors. One second about that.
Yes.
Okay, so over here, not super long because I don't have a whole lot of logic, but definitely not super intuitive. This is definitely a fault of like Rx, but it's kind of unavoidable. Because if I were to click back on these, it's like, well, where did this actually come from? It's not that easy to tell.
Yeah, can you trace it to the, like...
Let's find out. So that's internal. That's internal. No. No, you can't. So,
Yeah, it gets pretty tough.
yeah, that is definitely one of the harder things to learn. That's why the side effects are kind of useful for debugging purposes if you try to just put print statements in those, or breakpoints too.
Yeah, I think it kind of just pushes you to debug differently than you're used to, maybe. Like, you're used to being able to set a breakpoint and look at the stat tricks.
Right.
Well, with this, you may set breakpoints in your like maps or flat maps, and that's how you know where it came from, or you do those like, on, or do on next or whatever, put a print statement. And like, so, it's just different, and you have to learn how to use it like in that way. That's been my experience, but yeah, I think the stack trace is
That's definitely one criticism of it. And yeah, if I want to be fair, criticisms of Rx, that's definitely a hard thing. It's a little bit weird to wrap your head around. Like if I were to first show you this without having to explain anything else, it might be really difficult to understand what's happening. So to try to get new people, especially if you work on teams, to get into the whole Rx thing, it's kind of like everyone has to be on board or it doesn't work.
yes.
And I'm lucky I work in a really small team of basically me and one other person, so I can kind of force them to do it. But, not yet.
And you were mentioning a little bit too, like what types of projects you would or wouldn't use it on. It probably depends on your team a little bit too, but like would you try to use this on most things if possible?
So, like I said before, you can pretty much do anything you want to with Rx, and it definitely is the have a hammer, everything's a nail kind of approach. Cases where I definitely 100% want to use it every time with network requests, I just think it's easier to compose my logic that way, especially when you have a lot of complicated stuff. A lot of the applications I currently work on have a bunch of simultaneous uploads and requests and things that happen all in the same. They're all done using operation queues, and this code was written in 2013, and I hate it, and I want to update it. And so for that reason, I really like Rx. It's much cleaner. I just feel like I have better control over it. Looking at fabric and all the current crashes and that download stuff right now, I have another reason to want to change it too. But the network requests are good. If you want to do UI finding, I think it's kind of neat. The table view thing, the example I showed here is very simple. If you want to do more complicated stuff, like if you have a table view with multiple sections or different types of cells, there's the Rx data sources library in the RxSwift community repo. They can give you much more control over that. By default, the table view extensions from RxCocoa are very limited. It's more like a proof of concept for very simple use cases.
Yeah, I don't even think it does like subtitle or something like that.
No,
Just the out of the box one.
yeah, well, you have to give it a cell identifier, and internally, literally force some wraps to help with the source code. And so if you use the DQ cell identifier, and then it force some wraps it. So if you don't register that, you're kind of screwed. But if you want to use a base table view, you can't pick the style. You have to just use that whatever the default is.
Yeah.
But again, Rx data sources does let you pick between it, and it gives you much more control over it. I just didn't use it because again, I'm trying to show you like as close to out of the box as you can to get a simple example. Frankenstein. Oh, it did become Frankenstein. Yeah, no, it definitely can get crazy. I don't have a great example. Actually, I do, which is that link I showed before. I'm not going to pull it up because I know we're running late on time anyway, but I'll get this to Pat and I'll get on the Cocoaheads GitHub. So if you're interested, check that out. It's wild. If you want to see what people can really be pushing the bounds of this stuff, it's there.
Yeah, so we'll have we'll fork your project to the Cocoaheads GitHub. And we'll get your slides and all that will be available.
It's already on the README too.
Cool, awesome. So yeah, we probably need to wrap up, but if you want to hang out for a little bit and you've got questions from Travis, feel free. We've got more pizza over here if you didn't get some earlier. Thanks again to Alupa for having us. You guys are awesome. And thank you all for coming down. It's been fantastic. Travis, thank you so much for your presentation.